So our homework for tonight, it says find the perimeter of a figure formed by the vertices. And we have, the first problem is negative 4, 8, 4, 8, negative 2, 11, and 2, 11. Number 2 is 0, 0, 0, negative 9, and 2, negative 9. Number 3, 6, 0, 6, 5, 11, 5, and 12, 0. And number 4, negative 4, 0, 0, 6, and 3, 0. Copy that. Okay, everybody copy the home plate by now? All right, turn your graph paper over to the blank side. Set it up for Cornell notes. You do need a Fourier model. So our objective for today, I can solve for the missing side of a right triangle using the Pythagorean theorem. Let's read together, 1, 2, 3. I can solve for the missing side of a right triangle using the Pythagorean theorem. So today's going to be the last lesson on Pythagorean theorem. We already did the first lesson. I did the approach. I showed you how Pythagoras came up with a pattern. You guys remember that? And then how he was recruiting other mathematicians. He called them the Pythagoreans and stuff like that. But I want you to fill out a Fourier model for a right triangle. Right triangle. So I want you to write the definition, one example, one non-example, and a couple hashtags without looking at your notes. What is a right triangle? Give a definition, one example, one non-example, and a hashtag. Give you some time. Go. All right, check with the neighbor, see what they got so far. Definition, one example, one non-example, hashtag. Be nice. All right, here we go. Definition. Who wrote a triangle with 190-degree angle? Who wrote a triangle with a right angle? Either one is correct, yeah? Examples? Non-example? And a couple hashtags, yes? All right. Now, do we need the steps? No, we already know the 4 steps that we've been using to solve for missing sides of the right triangle. So you can remember the 4 steps without looking at your notes. Okay. So I heard a squared plus b squared equals c squared, so you write it, substitute, simplify, and solve, yes? All right, so last week, like I said, we introduced the Pythagorean theorem through Pythagoras. He found the pattern that it involved a right triangle. You guys remember that? So we said that he found the pattern that there was a relation between the legs of the right triangle to the hypotenuse. Remember this? Yes? All right. So today, what I want to do, though, is do an approach very similar, but now we're going to use area models. So look up. I'm going to sketch up here kind of like the end of your Fourier model. Your Fourier model should look something like this. You guys see it? I'm at the bottom portion of the Fourier model. Do you guys see it? Okay. So what I want you to do, I want you to sketch a square about right there. And I want you to place a point on the vertices, a point on each vertice. And then, once you sketch your square, nice and straight like mine, I want you to do another one right next to it. Something like this. There you go. All right. Everybody got it? Okay, I'm going to zoom into the first square that I sketched. Let's see. There it is. Okay, I'm going to focus on this one right now. So when we covered area models, I said there's an easy way of coming up with area models using a distribution. You guys remember that? So check this out. I'm going to label first this side. So let's see. Halfway is about right here. A little bit further down, about right there. There's a long segment and a small segment. I'm going to label this one A and this one B. Do the same, please. I'm going to do the same thing to the bottom segment down here. First of all, halfway is about right here, but I'm going to go a little bit further to the right, about right there. And once again, the long segment is A, and the smaller segment is B. Does everybody see what I did? Okay, next. So what we're going to do, we're going to sketch a straight line from here this way. And then from the bottom one up like so. We are actually doing the area model. You guys see it? You know how to fill this in? Given these measurements, yes? A plus B, fill these in. And then from there, I want you to write the new area simplified down here. Okay? Give you some time. Hurry up, please. All right. So let's see. Who got A times A is A squared? Yes. A times B, that's AB. Yes. B times A in alphabetical order is AB. And B times B, that's B squared. Does it look familiar? Yeah? And then remember when we did the area model, we started with this one, brought it down, so we write A squared. You guys see the peanut right here? So if we combine like terms, what do we have next? We're not multiplying, we're combining. AB plus AB is 2AB. Then at the end we bring down the last term, which is B squared. So far so good? 1AB plus another AB is 2AB. Okay. So let's go to this one over here. Keeps moving. There you go. All right. Notice that it didn't move by itself. All right. Be nice. So halfway there, a little bit further down, plot your point. Once again, we label this A, B. Halfway there is about right here, a little bit to the right, about right there. And once again, we label it A, B. However, this one we're going to do a little bit different than the previous one. Look up. Now I'm going to go to this side. Halfway is about right there, a little bit further up. A, B. And then this one halfway is there, a little bit to the left, is right there. So I'm going to label this A and B. Does everybody see? Okay. So like I said, this is going to be a little bit different than the other. The other one was straightforward, straight across, but this one we're going to connect the points diagonally. Look up, this point to this point to this point, this point to this point, and this point to this point. What? Oh my goodness. All right. It's a little crooked on mine. I don't know why. Anyways. All right. So, look up. Does everybody see this little piece right here? It's a right triangle. That is correct. So what would be the area of this right triangle? Talk it over your neighbors. What would be the area for that one? I'm talking about the triangle. What is the area of this triangle? Okay. Reagan, what would be the area? No. I'm not talking about the angle. I said, what would be the area of that triangle? Kind of like over here. The area of this rectangle is what? AB, because we multiplied A, which is this side, times B, which is this side. A times B is AB. Now, for you that don't see it, I said, what is the area of this triangle? Similar to this one. You divide by 2, so therefore this would be what? 1/2 AB. That is correct. Damn. So if that's true for that one, what is this one? 1/2 AB. So what is this one? 1/2 AB. So what is this one? 1/2 AB. Okay. Yes. We'll get there. Next, we need this one in here. So now, focus on this triangle right here. It's a right triangle, isn't it? This segment is A, this segment is B, so what is this one? So if this is C, what would we label the inside of this area, everyone? Say it again. C what? C squared to the second power. Why? Because it's C times C. Yes? All right, bless you. All right, so with that said, I want you to gather the areas and rewrite them down here next to the other one that you did. All these areas, there's 5 of them, yeah? Write them right here combined. Let's see what you get. Who's got it? Julian.
2AB plus C squared.
Hands if you got that. That is correct. 1/2 plus 1/2 is 1AB plus 1AB is 2AB plus the center is C squared. Okay, let me zoom out. Yeah. It is in standard form. Okay. Now, do you agree that this square is the same as this square?
No.
Didn't I just copy and paste it over here? I just did different areas, but it isn't the area inside the same as the other area? So let's do this. Put equal right there. Next, see if you can simplify one more step and see how that develops. See what we get. One more step. What can you do? Look at it. What can you do? And see what we get. All right, share with your neighbors, see if they see it. All right, so who saw that we couldn't simplify anymore on each side, but we saw that they had something in common, didn't they? So we subtract 2ab from each side, subtract 2ab. This cancels, so we're left with a squared plus b squared equals c squared. And that's another approach to the Pythagorean theorem. So what did we use? Area model. So what did we find? So check this out. On this one, what did we take away? 2ab, is that correct? So that means we took away all the triangles, didn't we? So watch, if I take out all the triangles, there it is. What did I take out from this side? The 2ab, this ab and this ab, yes? And I'm left with this square and this square. So what does that leave us? Let's see. That was good, right? It goes back to the same thing that we've been working with, which is a right triangle, and it gives us a squared plus b squared equals to c squared. All right, enough of deriving the Pythagorean theorem. So that's another approach. There's other approaches which I'm not going to show you because it will take a long time because there's different mathematicians that have done it. But I want to get to the next example, though. Yeah, last week we covered this one, yes? We covered this one, yes? And then from there we went to the coordinate plane. We plotted 2 points, and then we found the distance between the 2 points. Is that correct? Okay, let's crank it up a notch, yeah? Copy this one on your graph paper. Top left. If you want, just write perimeter with a question mark, and then write the 4 coordinates. But the instructions are, what is the perimeter of the figure formed by the following relation? What is a relation? A group of different coordinates, yes? So how many coordinates do they give us? 4. Negative 11, 16, negative 11, 7, negative 2, 7, negative 2, 13. Once you copy that, I want you to plot the points. Excuse me. So as you're copying, I'm going to start plotting my points. Negative 11, 16, negative 11, 16, negative 11, 7, negative 11, 7, negative 2, 7, and negative 2, 13. Next, you're going to connect these 2 bottom points like so. This one to this one. This one to this one. And this one to that one. So let's see. How do we find the perimeter of any figure? Everyone. Side plus side plus side plus, in this case, how many sides? 4. 4 sides. Okay. So what does that mean? That we need to label our sides. So what does it measure from here to here? Count it, please. Who's got it? Very good. 9 units. How about from here to here? This height right here. 9 units. Okay. So far we got 9 plus 9. What does this measure? 6 units. So we have plus 6. So what are we missing? This one, but it's diagonal. Let's see. What can we do to find this distance? You guys see it now? So what is this height right here? 3. What is this? 9. So that means we're going to label this what? C. Therefore, a squared plus b squared equals c squared. 3 squared plus 9 squared equals c squared. 9 plus 81 equals c squared. 90 equals c squared. And how do we cancel that squared? Square root. C is approximately square root of 90. So for home play, I don't want you guys to use calculators. I want to see the work on how to find the decimal for it. Down to the nearest tenth. So square root of 90 is between what two numbers? Between 81 and 100. So that means this is going to be approximately 9.4 to save time some time. 9.4 units. Once again, no calculators, please. Therefore, let's substitute that into our equation, which is what? Plus 9.4. 9.4. So the perimeter of that figure, which is all the outer, 9 plus 9 plus 9 plus 6, that's 33.4, and it's approximately units. So which is the only one that's going to give you a little bit of a problem? Oh. The diagonal ones, right? Is that correct? So you can use right triangles for that. So your home play for tonight is only 4 problems. Yes, for tonight, not fortnight. You do have home play. It's these 4. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.